In February of 1990, a tiny spacecraft billions of miles from home turned its camera around and took one last look at everything it was leaving behind forever. What it captured in that final photograph would make grown scientists weep, inspire one of the most famous quotes in human history, and change the way our entire species understands its place in the universe. This is the story of Voyager 1's most unbelievable images, the pictures that shouldn't have existed, and the final photograph that almost never got taken at all. Voyager 1 launched from Cape Canaveral on September 5th, 1977. It was never designed to be a poet. It was a machine built by engineers to measure magnetic fields, chart radiation belts, and study the chemistry of distant worlds. Nobody expected it to become one of the greatest visual storytellers in the history of space exploration. But that is exactly what happened, and it started with Jupiter. Interestingly, Voyager 1 actually launched slightly after its twin, Voyager 2, even though it carries the number 1. Mission planners chose a faster trajectory for this spacecraft, reaching Jupiter and Saturn ahead of its sibling, at the cost of ruling out any further planetary encounters afterward. On board, tucked away from the cameras and sensors, Voyager 1 also carried something almost nobody expected from a scientific probe, a golden record containing sounds and images of Earth, greetings in dozens of languages, and music from across human history, a message in a bottle tossed into the cosmic ocean on the chance that someone, someday, might find it. By January of 1979, Voyager 1 was closing in on the largest planet in our solar system, and it began doing something remarkable. Every 10 hours, once for every rotation of Jupiter, it snapped a photograph. Scientists stitched movie, and for the first time in human history, people watched a living, breathing storm system swirl across an alien world in real time. The images kept getting sharper as the spacecraft crept closer, and details that no telescope on Earth had ever resolved began to emerge from the noise. Then came the image that stunned everyone. On February 25th, 1979, from more than 5 million miles away, Voyager 1 captured a close, detailed view of the Great Red Spot, a storm larger than Earth itself that had been raging for centuries. For the first time, humanity could see individual cloud bands twisting and curling around this ancient storm. Some structures as small as 100 miles across resolved clearly for the first time in history. People had stared at that reddish smudge through telescopes for hundreds of years. Now it looked like a living thing, a churning ocean of gas with structure, motion, and depth. Earlier that same month, on February 5th, 1979, Voyager 1 captured another striking frame, Jupiter alongside 3 of its 4 largest moons at once. Io, Europa, and Callisto, all lined up against the swirling backdrop of the planet's clouds. Io appeared with its strange brownish-yellow surface, Europa glowed bright and smooth, and Callisto sat dim and heavily cratered in the corner of the frame. It was the closest thing humanity had ever seen to a family photograph of an entire miniature planetary system, one that made it obvious just how different these 4 worlds truly were from one another, despite orbiting the same planet. As Voyager 1 continued its approach through late February and early March of 1979, the level of detail kept increasing. By March 1st, from just under 3 million miles away, the spacecraft photographed the Great Red Spot, alongside one of Jupiter's smaller white oval storms, giving scientists their first real comparative look at how different sized storm systems behaved next to one another. Nothing on Earth had ever offered a comparison like it, because nothing on Earth came close to matching the scale of what Voyager was now seeing. But Jupiter had one more secret waiting, and it wasn't in the clouds. It was on one of Jupiter's moons, a small, strange, orange-colored world called Io. Nobody expected Io to be interesting. It looked like a diseased pizza, mottled with yellows, oranges, and reds that scientists couldn't quite explain. Then, on March 8th, 1979, an engineer named Linda Morabito was analyzing one of Voyager's photographs of Io, checking navigation data, when she noticed something strange curving off the edge of the moon. It wasn't a shadow, it wasn't an error, it was a plume, a 200-mile-high cloud of material erupting directly off the surface into space. She had just discovered the first active volcanic eruption ever seen on another world beyond Earth. Think about the sheer improbability of that moment. Humanity had sent robotic spacecraft past dozens of moons and planets before this, and every single one of them had been geologically dead, frozen relics of a violent past. Io was different. Io was alive, tortured by the immense gravity of Jupiter, its interior squeezed and stretched until it melted, venting molten sulfur hundreds of miles into space. Scientists later identified massive eruptions coming from a volcano they named Pele, plumes so enormous they dwarfed anything ever recorded on Earth. This single photograph rewrote the textbooks. It proved that volcanic activity wasn't unique to our home planet, and it opened up an entirely new field of study almost by accident. What made the discovery even more remarkable is that it almost wasn't noticed at all. Morbido wasn't looking for volcanoes that day. She was simply doing routine navigation work, using background stars and Voyager's photographs to confirm the spacecraft's exact position in space. It was only because she happened to boost the contrast on one particular image, searching for faint stars near Io's edge, that the plume became visible at all. A discovery that reshaped planetary science almost slipped by unnoticed, buried inside a photograph that was never meant to be studied for its content at all, only for the coordinates hidden within it. In the days that followed, scientists went back through earlier Voyager images with fresh eyes and found even more evidence of volcanic activity scattered across Io's surface. Dark spots surrounded by strange-colored rings that suddenly made perfect sense as calderas and lava flows. Within a week, a second active plume was identified, then a third. By the time Voyager 1 completed its flyby, at least 8 separate volcanic eruptions had been confirmed on a single small moon, more active volcanism in one snapshot than exists across the entire rest of the solar system combined, Earth included. If you're enjoying this journey through the most incredible images ever captured by a single spacecraft, do me a favor and hit that like button. It genuinely helps this channel grow. After Jupiter, Voyager 1 pressed on toward Saturn, arriving in November of 1980. Here, the spacecraft delivered images that made Saturn's rings look less like a flat disk and more like a bafflingly intricate structure with thousands of individual ringlets, gaps, and strange braided patterns that nobody had predicted. Some of the rings appeared to have kinks and twists in them, structures that seemed to defy the tidy physics scientists expected. It took years of follow-up research to explain some of what Voyager 1 saw in that ring system, and some details remained mysterious for decades. Voyager 1 also turned its camera toward Titan, Saturn's largest moon, a world wrapped in a thick, hazy orange atmosphere thicker than Earth's own. The images were almost disappointing at first glance. Just a smooth orange ball with no visible surface features. The haze was so dense it blocked any view of what lay beneath. But that mystery itself became one of the most important discoveries of the mission. Titan had weather, chemistry, and an atmosphere so complex that scientists would spend the next several decades trying to figure out what was hiding underneath those clouds. It took another spacecraft, Cassini, arriving decades later, to finally pierce that orange veil and reveal lakes of liquid methane on the surface below. Voyager 1 also photographed Saturn's smaller moons during this encounter, capturing the icy, heavily cratered surface of Mimas, dominated by a single massive impact crater so large it gave the tiny moon an uncanny resemblance to a certain fictional space station. Every new moon the spacecraft passed seemed to reveal its own strange personality, some smooth and icy, others scarred and battered, each one a small mystery answered in passing on the way to somewhere else entirely. After the Saturn flyby, something happened that very few people talk about. NASA made the difficult decision to send Voyager 1 on a trajectory that would take it close past Titan, and that trajectory came at a cost. It permanently ruled out any future flybys of Uranus, Neptune, or Pluto. Voyager 1 was now committed to a one-way path up and out of the solar system's flat plane, climbing higher and higher above the orbits of the planets, heading toward the empty dark of interstellar space. Its cameras, having done their primary job, were essentially finished with planetary photography. For nearly a decade after the Saturn encounter, Voyager 1's imaging system sat mostly dormant as the spacecraft simply coasted onward into the black. Then, in 1990, an idea resurfaced that had been proposed nearly a decade earlier by a scientist on the imaging team named Carl Sagan. Sagan had suggested that before Voyager 1's cameras were shut off forever to save power for the long interstellar journey ahead, the spacecraft should turn around one final time and take a picture of home. Not for any scientific reason. There was almost nothing of scientific value in photographing a planet that would appear as less than a single pixel from 6 billion kilometers away. Sagan wanted the photograph purely for its philosophical and emotional weight. Many engineers pushed back. Turning the spacecraft's cameras toward the sun risked damaging the delicate optics with direct sunlight. The mission team had limited power and limited time before the cameras needed to be powered down permanently. But Sagan persisted, and eventually mission managers agreed. It took nearly 6 months of careful planning and calculation to prepare for this single photographic sequence, because Voyager 1 wasn't just going to photograph Earth. It was going to attempt something no spacecraft had ever tried before, capturing a family portrait of the entire solar system in a single sequence of 60 images. On February 14th, 1990, at 4:48 in the morning Greenwich time, Voyager 1 executed its final photographic sequence. It captured the Sun, Venus, Jupiter, Saturn, Uranus, and Neptune, along with Earth, all from a vantage point roughly 6 billion kilometers away, high above the plane of the solar system. Mercury was too close to the blinding glare of the sun to photograph. Mars was washed out by scattered sunlight bouncing around inside the camera. Tiny, distant Pluto was considered too small and too dark to even attempt. but Earth was captured. And in that image, our entire planet, every mountain, every ocean, every person who had ever lived, appeared as a fraction of a single pixel, caught inside a scattered beam of sunlight, a tiny, pale, bluish speck suspended in a shaft of light against the overwhelming darkness of space. Just 34 minutes after taking these final images, mission controllers sent to the command that powered down Voyager 1's cameras permanently, conserving energy for the decades-long journey still ahead. When Carl Sagan later looked at this photograph, he wrote words that have since become some of the most quoted lines in the history of science communication. He described that pale blue dot as the only home humanity has ever known, a single point of light holding every joy, every war, every civilization, every person who ever existed, all suspended on a mote of dust floating in a sunbeam. He spoke about how that photograph should humble us, how it revealed the smallness of our conflicts and the fragility of our shared existence, all playing out on a planet too small to even resolve as more than a speck from beyond the orbit of Neptune. What makes this photograph so extraordinary isn't the technical achievement. Although capturing a barely visible dot from 6 billion kilometers away with 1970s era camera technology was genuinely remarkable. What makes it extraordinary is the choice behind it. Nobody needed this image. There was no experiment it served, no data point it contributed to planetary science. It existed purely because one scientist believed that seeing ourselves from that distance mattered, that perspective itself had value, that a photograph could do something no measurement ever could. After that final sequence, Voyager 1's cameras never took another picture. They were switched off to save the spacecraft's dwindling power for its remaining scientific instruments, magnetometers, plasma detectors, and cosmic ray sensors that continued gathering data as the spacecraft pushed outward. In August of 2012, Voyager 1 crossed the heliopause and became the first human-made object to enter interstellar space, carrying with it the visual record of everything it had seen along the way. It's now well over 160 astronomical units from the Sun, farther from home than any object humans have ever built, still transmitting faint signals back across the void, using a radio system now decades beyond its original design life. The pale blue dot photograph didn't become instantly famous the moment it was received on Earth. It took Sagan's own writing, published a few years later in his book of the same name, to give the image the cultural weight it carries today. He described looking at that speck of light and thinking about every leader and every conqueror in human history, every triumph and every tragedy, all of it occurring on a world so small from that distance that it barely registered as a smudge of light inside a single sunbeam. He argued that the photograph was a call toward humility and toward taking better care of one another, since, as he put it, there was no other place in sight to which our species could escape. Decades later, that message has only grown more resonant, quoted in classrooms, planetariums, and documentaries around the world, printed on posters and engraved on monuments, all tracing back to a single, barely visible pixel captured almost as an afterthought before a spacecraft's cameras went dark forever. Voyager 1 began its camera's story by discovering an alien volcano erupting on a distant moon, evidence that other worlds could be as dynamic and alive as our own. It ended that same story by turning around and photographing the only place in the entire universe we actually know for certain harbors life at all. From storms bigger than planets to rings more complex than anyone imagined, to a single dot of light containing everything we have ever known, Voyager 1's camera told the story of an expanding universe and, in its final act, brought that story quietly back home. If this deep dive into one of humanity's greatest achievements resonated with you, make sure you're subscribed, because there are so many more stories like this waiting to be told.